I'm going to be doing the problems from today's Atcoder Beginner Contest, which just based on, my friend's standings, it seemed like a really difficult contest. Just the overall standings also made it seem pretty tough, so we might give up partway through, but we'll see. Cool. So I guess I'll just wait for a couple more people to trickle in, and I guess I'll try to make sure the stream is on as well. Cool. Yeah, I'll just set up the links and stuff first, I guess. Going to be solving the problems. And if you're just tuning in for the first time, definitely check out my YouTube and my Discord as well. Cool. And got my whiteboard. I'll share a link to that as well. Cool. Alright. I guess I should get started. I assume that like A and B are pretty quick and simple anyway. And because I'm going to be trying to solve the problems, please don't like spoil the solutions. Cool. Alright, so let's get started. Cool. I see. A is a geometry problem. Very cool. Okay. So for A, let's see. What? This is very weird. So the ball is invisible. Okay, got it. So we just had to check if the ball is invisible when Aoki, when it reaches Aoki. This is actually, even this is harder for a, I feel like this is hard for an Atcoder Beginner Contest A, but of course it's a little bit, it's not too hard anyway. It's kind of just a relative thing. But yeah, this is definitely geometry, right? Because here the ball moves linearly. And there's a distance here in meters, so definitely keep that in mind. So I guess what we want to do is just figure out the position at the beginning and at the end, and then this is a fairly straightforward implementation problem. Basically what you want to be careful with here is the less than versus less than or equal to. And this is just my personal preference, but I like to write ranges like this, so that way it's kind of reminiscent of L is less than D is less than R. I think in Python you can actually just write them exactly like that, but Cool. So let's... Nice. Alright, so we got A. Okay, so this seems like... I see, okay. So here they're just telling us to take all the elements from A that are not equal to X and then print them in the same order. So this is a pretty straightforward problem. I guess it's here as kind of a trick. So the most straightforward implementation is something like... Well, I'll start writing the code, I guess. So the most straightforward implementation is something like loop through A and delete the elements. But that'll like get time limit exceeded. So I think the easiest way to do it is to just create a new array for the answer. And then we can just print that instead. Cool. Yeah, I agree that B was actually kind of more like an A, other than two things actually, which if you're a more experienced competitive programmer, which most of you probably are, you don't even notice. But I'm pretty sure from my experience, and it took me like many contests before I realized this, but I think that beginner contest A's never include like for loops or like any sort of loop. I think they always have a fixed input size. Like sometimes they'll have like a list of like 5 things and it's like easier to write it with a loop, but they'll still frame it like there are 5 things like A, B, C, D, and E. And like you can write it without a loop via like copy pasting. So I think that for that, but I'm not sure if that's a formal constraint that they have or just like something that's usually true. If the order of elements... Oh, yeah. You can erase the elements in O of 1. Is that like you swap them all to the end and then you like shorten the vector? Cool, yeah. Okay, so some of these problems I actually did read earlier, just because like I was glancing through the problems in the standings, and this is one of them. And I guess I'll try to summarize my understanding of the problem on this diagram. In C, I used 12 if statements. Very nice. Oh, I didn't explain the problem yet. Yeah, someone wrote that they directly printed. I think that's fine as well. I generally like to save my answer in an array or something first. It's sometimes, I guess what I like to do is I like to separate the like problem solving from like the input and the output. So I think it's kind of nicer to do all the output at the end. That way you don't have any mistakes with output format. So anyways, for C, we had this problem of you have some grid and then some of the cells, like this is their example, some of the cells are black and some are white. And then they said the black cells form a polygon and you want to say how many sides it has. So like this is the example that they gave where it's a square or a rectangle or something. Right, you can kind of see pictorially here that you have a square. And I was kind of like, I didn't think this was a great sample. The reason being like, I don't know, if you had, like, I wasn't sure the spirit of the problem was supposed to be that like, this is how you draw well, it's not very good, but like imagine drawing like a diagonal square, right? Like, so is this like 4 sides or is this like 20 sides or something? I think it's supposed to be like 20 sides, but it's kind of weird to me that they didn't really have any explanation of that, and they also didn't even like show like a picture, like the way that I drew this picture here to show the cell. But I guess like they kind of say that like the cells are squares and that this square is painted black. So I think it's somewhat clear that it's supposed to be interpreted like this, but it's not completely clear. And yeah, so I think if only one cell is black, as someone asked, then I think that would be a square, so that would be 4 sides. How to perform an Atcoder because they have ad hoc problems. That's a great question, and the answer is the same as for most other contest platforms. It's not too exciting. The answer is just practice a lot. Try to learn as much as you can about like the principles behind the answers when you solve problems or attempt to solve problems, and then try to learn like the background information that you need. But then after that, it kind of comes down to just practicing a lot. Like just solve a lot of problems and try your best to like learn from all the problems you solve. But yeah, okay, cool. So this is kind of the implementation here might be a bit tricky, but I think in terms of complexity, we can do almost anything because they say here that height and width are only 10. So let's see, what's the cleanest way to do this? I mean, so the first idea I thought of is like go through all the cells and take all the like individual borders of the polygon that are just like these segments and then insert them into some sort of data structure. And then if you have like 2 segments that are together, like merge them. But that seems kind of annoying. So let's see. Maybe that is like an okay way to do it. Oh, cool. So someone in the chat said number of edges equals number of vertices. I heavily use this fact. That's actually a pretty nice way to do it. Definitely spoiled me a bit on the solution, but that is pretty cool. So the idea here, to kind of draw out an example, is if you count these, it's a little bit more straightforward than counting these long segments because you only have to look at kind of this one thing. So I guess the corners are going to be a set of 4 cells where 3 of them are one color and 1 of them is another color. Wait, I counted number of borders. Oh, by the way, someone's trying to do referral. What is referral supposed to do? Or like, what's your intention of referral? Let me know if maybe I can help. Okay, cool. So I guess that's a pretty straightforward implementation. So let's try implementing it. So, HW. So this is one of those cases where the input is in kind of a, oh, Koki Fige, thanks for the subscription with Prime. Wow, 2 months. Very nice. Thank you. Yeah, if anybody has Amazon Prime or Prime Gaming, you can subscribe for free, which is pretty cool. Yeah, so for problems like this, what I like to do is, whoops, I like to transform the input into a nicer format. I don't want to have to keep dealing with these strings the whole time while I'm solving the problem. Amazon Prime with Twitch just oh really? Like if you have Amazon Prime in India, it doesn't give you the Twitch Prime gaming benefit like it does in the US? Then that's super weird. Yeah, I think a lot of my audience, if you look at my analytics, are from India, and then I think the second most is like the U.S. So I guess I'll do this. Oh, I guess actually the nicer way to do this is this. Whoops. Cool. So this works. This is actually a super elegant way to do it. So this is actually a pretty nice problem. So definitely props to Nadim Shaikh for figuring that out and solving it that way. How is the answer not the number of borders? What do you mean? Like the answer is the number of sides of the polygon. But well, I guess I'll submit this and then I'll try to clarify slightly. So like if you mean the number of individual border cells, the answer is that if you have multiple borders in a row that form kind of a single line, that's still only one side. Right? Like this one, the answer isn't 12, it's just 4. Cool. And then someone said we have to count the number of black cells with 3 similar neighbors. Yeah, that's right. So after the insight from the chat that you can count the corners, the way that I counted corners is you have a corner only if you have 1 black cell and 3 white cells, or you have 3 black cells and 1 white cell. So what I did is I just took this 2x2 box, and then in the 2x2 box I XOR all the values. So it's if it's an odd number, then the XOR, so if it's 1 or 3 black cells, which is what we're looking for, then the XOR will be odd, and otherwise the XOR will be even. It'll be like 0, 2, or 4. Or, well, the XOR will always be 0 or 1, but, you know, it's like taking the sum mod 2, basically. Yeah, I don't... Alright, I guess I'll look at this implementation. But in the future, I think in general, like, Well, okay, let's see. What? Yeah, this is so long. This is how I was gonna do it. If I were not given that hint. um, at least I think it is. Okay, so this looks like you interpreted the problem correctly, but you probably just implemented it wrong. I mean, the implementation is pretty difficult, so that makes sense. It's probably pretty straightforward to sorry, I was gonna say it's straightforward to make a mistake, which is kind of a weird phrasing, but I just mean that I think it's pretty easy to just like try doing this problem and making a mistake. Um, cool. All right. So D is circle lattice points. They have a picture here. Um, and this was an interesting one because like when I looked at what was it like friends standings or whatever, I just have a bunch of random people on my friends list as kind of a sample, and like almost nobody got D, and there were a ton of wrong submissions. Um, so it's kind of interesting because it seemed like a pretty straightforward problem because of the constraints. So I guess I'll kind of go over my thoughts on it, and then I'll implement it, and then we'll see. We'll see if I get clowned the same way because that's always possible. So my thought was basically you have like some big circle, and we know that the coordinates are less than 10 to the fifth. So what this means is we can actually just loop through every possible x coordinate and calculate how many lattice points are inside that one vertical slice. So that was basically it for what I wanted to do for this problem. I was going to use binary search to find like the top and bottom borders and then like subtract them. Normally I always try to use like binary search instead of like floating point square root or anything like that, just because you know, it's best not to use floating point. But here it looks like the input itself is already a floating point. So in that case, maybe I'll just try using floating point directly and see what happens. So let's try this. So int, I guess I'll use a point class. So I guess what we want to do here, right, is we want to try all the x values. Center minus r, let's say -5 as well. Well, maybe that's not necessary, but yeah, we'll just try it. Center, whoops, whoa. Center plus r plus, and then what we're gonna do here is, wait, what? Oh, I see. Right, okay. So then I guess what we want to do is we want to find the x distance from the center, and then we can find the y range from the center that's acceptable. So what that would be is you would have r squared minus like delta x kind of squared. Right, so I guess I'll explain what we're doing here a little bit geometrically. So we know that for a circle, you have x squared plus y squared is less than or equal to r is stuff that's on or inside the circle. And this is assuming that we're centered at the origin. So we're going to kind of recenter at the actual center. And what we're doing here is we're just, r squared. So we're finding r squared minus x squared. And then we know that that's greater than or equal to y squared. So if this is negative, then we can continue. And if this is positive, then we do something with it. Oh, so I actually already see this can kind of have some errors if you pick the wrong epsilon, I guess. All right, we'll try this for now. So now I guess I just want to take the square root of that. And then what I want to do is I want to count how many things are within that of so the lower value of y would be center.y minus delta y. And I guess let's subtract epsilon. And then the high value of y would be center y plus delta y plus epsilon. And then what we would want to do after that is we'd want to round up for the low value. Or I guess we can round down. Basically what we want to do is we want to round these values in a way that lets us count the stuff inside them consistently. So let's see what that would be. I guess is there floor and seal actually? Huh. Okay, that seems fine. I'm being extra careful while implementing this because I saw so many people got wrong answer or something. So all right, let's see if this even passes the samples. Wait, what? Okay, cool. Oh, so this is super wrong. What? Oh, right. Here I want to take floor. Okay, so now I guess let's submit this and see what happens. Okay, nice. So we got wrong answer on probably a few test cases, on 3 test cases. And it looks like we got wrong answer on some handmade cases. So yeah, this is probably a floating point issue. So is there a way for us to solve this problem nicely without using floating point at all? And I think the answer may be yes, right? Because here we kind of have this. Each of these have at most 4 digits after the decimal point. So I think that perhaps the nice way to do this is to translate everything into integers by multiplying by 10 to the fourth, and then kind of proceed from there. And then we're going to try to find, right, so then we're not going to use any square root or anything like that. What we're going to do instead is we're going to find lattice points that are multiples of 10 to the fourth. So let me just save this file and then delete everything. Cool. So string s. Oh, I can probably just read it and multiply it. What is round, though? Is that what I think it is? I guess it rounds a double to the nearest double. That seems like it should be fine. Okay, cool. Let's just print this to make sure that we're like even approaching this right at all. Okay, cool. Yeah, this seemed like it. Wait, hold on. Okay, cool. Yeah, this seemed like it multiplied everything as we wanted. Yeah, so as 20 pixels is pointing out in the chat, the best way to avoid things like square root is to use binary search instead. This adds like a small constant factor, but that's fine. Well, it's a log factor, but it's kind of like a constant based on like your input size, like okay, so what we're gonna want to do here is we're gonna want to take the last. Here, I'll actually do this. So we want to take center.x minus r, and then we want to round that up to the next multiple of z, which is, this is kind of a weird way to do it, but I believe it's correct. And then for x high, we want to add r, and we want to round it down, which is a little easier. And now what we want to do is we want to select y such that we want to find the lowest value of y and the highest value of y. So one way that we can do that is yeah, I guess we can just binary search for how much away from the center you can go. Yeah, so we can binary search for dy, exactly. The reason that we can do that is because dy is always going to be an integer now that we've now that we've kind of rescaled everything. So we're going to find the first value that's greater than this. Yeah, that sounds right. And then we're going to subtract 1 to find the last value that's less than or equal to this. And then I guess the maximum value we can pick could be something like 1e9. I guess we want to use longs. Cool. I guess we could also just do this. Yeah, cool. So R will always be larger than this, or R plus 1 will. Okay. So now what we want to do is equals. We're basically replicating our previous code. And let's just implement this. That way it reduces the chance of us making any like small mistakes. Okay, cool. So we're gonna do y low would be and then y high would be get floor, and then we would want to do something like this. And now we can try running this. Okay, nice. My output on sample 1 was 9,000. That's actually pretty cool. So clearly there's some. Oh, I see. So 20 pixels asks in the chat, if you have dy, the answer is 2 dy plus 1. So I'm actually not quite sure if that's correct. The reason for that being, oh, whoops. No wonder. Okay, cool. So the reason I think that's not quite right is because center.y isn't always an integer. Oh, sorry, by integer here I mean like it's not always a multiple of 10 to the 4th. Let me rerun this. Okay, there's something very wrong here. I'll fix that in a second. But basically the idea is that the center, right, is not always at like an integer point. So you could have a case where, oh, like in this example, there is 1 point if you go up from the center, but there's 0 points if you go down from the center. Yeah. And like there also is no point exactly at the center. Because, right, as we said, our center.y here is kind of like scaled. Okay, so something's very off here. Let's see what it is. Oh, I also want to do this. Maybe that'll fix it. Okay, cool. So there's still a wrong answer on this sample, and it's actually wrong by quite a bit. This should be long to avoid overflow. And now this is slightly off. Okay, so let's actually see what's going on here. Let's first just check to make sure this is even reading the input correctly. So 999.99. Okay, so that seems good. That seems good, and that seems good. Yeah, so there's no rounding errors while reading the input at least. Oh, my floor and seal take ints again. Maybe that's the problem. No, I guess not. Okay, so I definitely see now why this is such a hard problem. Like, I was kind of thinking it was gonna be an easy one. Oh, that's pretty cool. Yeah, the output is pretty close to pi. Oh, I guess that makes sense, right? Since it's finding the area of this giant circle. At first I was like, whoa, how did they do that? But okay, so that's not helpful. Okay. So let's see. How should I even go about debugging this? Maybe this get seal function is wrong. Well, this seems right, and this seems right. Oh, okay, so, get floor is wrong here. So get floor appears to be rounding. Wait, I'm actually a bit confused now. Wait, does C++ division round towards 0 for negative numbers? I always thought it rounded down. What? LearnCpp.com. Oh, okay. So it always rounds towards 0, which is why this is just wrong. That's kind of annoying. Okay. So what's actually the best way to implement floor division? Like, cleanly? I guess, like, So this would be the remainder, and then we want to subtract this. Okay, so now this does what we expect. Wait, but is seal still wrong then? Probably. Yeah, so seal here is also wrong for the same reason. So I guess what we want to do is... Oh, can I just do this? It's like a little silly, but... Okay, cool. So that was easier to think about. Okay, cool. So now I think this should be right. And basically what we've done is we implemented our previous solution, but we took advantage of this constraint. There's at most 4 digits after the decimal point. So we just turn everything into non-floating point types, into whole number types. Which is kind of funny because, right, so if you were here when I started this problem, the first thing I said was like, oh, normally what I would do is do this using integer types and avoid floating types, but maybe because they gave us this stuff as a decimal, I should just use floating point. So they kind of bamboozled me there. But yeah, this is not a very common trick because usually they just don't give you decimals, but it showed up in a recent grand contest, actually. Let me find it. It was the one written by Eric Doe. So there was this one. You're given a bunch of real numbers, compute the number of pairs such that the product is an integer. And then they say that AI is given with at most 9 digits after the decimal point. So the way that you did that, which, oh nice, I did it in Java, is you want to convert the input by multiplying everything by 1,000,000,000 at the beginning. And now you just have this problem with a bunch of integers, and to find something that's an integer here, it has to be a multiple of 10 to the 18 after this. So this is kind of analogous to, in this problem, we wanted to find integers, so we multiply everything by 10 to the 4th, and then we found things that are multiples of 10 to the 4th. Here, z is 10 to the 4th. Cool. I should probably add this floor division and ceiling division to my snippets or something, because it seems like a pretty easy mistake to make. Is there any way to find integers in the whole square and how many of them are outside the circle? So like you're saying like draw like a bounding box around the circle and then count the ones outside. I think the way that I would do that would be like the same amount of work or more. Because you would like, I would still do that by like taking each x coordinate, and then for each x coordinate on like the lower half, I would find like the height of this bar under the circle, and you would do that basically the same way. And then at the top, you would do the same thing, and then it kind of boils down to like the same solution, but with more, possibly with more work. Possibly slightly less work, but I don't think it would be that much different. The fastest solution passed was square root using long double. Yeah, so using binary search instead of square root is always going to be slower. And long double, I guess, is a cool trick. I've never actually used it before, but my understanding is that it's just an even longer double with more precision. But I think in general, if you can avoid thinking about epsilons or precision or floating point, it's best to, because it's really difficult to debug, at least for me personally. So it ends up being a bit like painful to figure out. And then will I be solving SRM 799? I don't know. Probably not. I usually skip Top Coder just because I personally don't like the format as much as other contests. I also frankly think Top Coder Division 1 is too difficult, but maybe that's just for me. I feel like usually in Div 1, like, I'll solve A, and then, or like I'll solve the 250 or 300 or whatever it is, and then I'll like almost solve B, or sometimes I'll solve B, but frequently I end the contest solving one problem, and it feels kind of like, I don't know, it's a little weird. Alright, time to read E. Cool, so I haven't read E, and someone's like, I use DFS, why didn't it work? I don't know. Actually, I did read E, but I haven't done it yet, and I didn't read it on stream, I guess is what I meant. But DFS probably, that doesn't sound like it's gonna work because you want to find the minimum something, and DFS is pretty bad for finding the minimum. You usually just frequently DFS will find you like the maximum. Like it won't actually find the maximum, but the way that DFS works, like you typically go through a lot of the graph to get to any given thing. Okay, cool. So for E, we basically have some graph. All right, I guess I should have, maybe I should clarify this, but like, because I'm trying to show like my solving process and I'm trying to solve the problems, so if you've like done the problems, please don't like just tell me the solution. Yeah, just like to avoid like spoiling me excessively. But yeah, my idea for this problem when I read it earlier was Dijkstra from each node. So I think that is what I'm gonna see if I can make that work. But yeah, so let's draw one of the graphs from the input. So we have some graph, and then wait, what? 2, 3, 3, 1. Okay, and then 4 goes to 3. Okay, so what we want to do here is we want to find the shortest walk that starts at a town and then goes back to that same town. So let's say we're starting here. Then what I would do, like the Dijkstra idea, is to use Dijkstra to find the shortest path to every other vertex. And then for each other vertex, if it points back to the original, then set your answer to be like, so like if your original vertex is U, then we go over all V, and it's the distance from U to V plus like an edge from V to U. And that would give you your cycle. And the idea here, right, is that if you go somewhere and then back to the start, you can decompose that into like two parts, the going somewhere part and then the going back to the start part. And this should be fast enough actually, right? Because Dijkstra for this graph would take like 2000 log 2000 time or something like that. So you can just do it separately from each starting vertex. And I think just solve the problem that way. But I think like the standings made E seem like it was kind of tricky, so maybe there's more to it. Then I have this nice Dijkstra template, courtesy of Socket, so let's see how to use it. I haven't used it before, but I remember it's a bit complicated. But yeah, alright, cool. So let's read the input. So yeah, I guess let's see how to use this library class. Oh, okay. So first we create a weighted directed graph. Oh, cool. So I'll actually just use this instead of my own struct. And then we can call shortest path tree by passing in a source. Okay, very cool. Someone said I thought of it using SCC, but got all confused there. Yeah, so I'm actually not sure. Like this does kind of remind of the definition of SCC, right? Or strong connection, where it's like you can go from a node back to itself. But I'm not really sure if there's a useful way to use the SCCs once you find them. Like, I guess you only want to compute the distance from stuff to other stuff in its SCC, but like you could have the whole graph being one SCC, in which case I don't think that really helps you with any optimization. And then you kind of end up back with the same solution that we had here. Well, so if you find all possible routes, that would actually take like a lot of time using DFS, and you would get time limit exceeded. So you probably didn't actually find all possible routes. You probably like missed one. Okay, cool. So here I guess we printed our, or we've created our graph, and then what we want to do is we're going to go through each starting vertex u, and what we're going to do is we're going to find the shortest, wait, we're just going to start from only u, and then let's see what the, oops, I'll make this a bit bigger. Let's see what we're supposed to pass in here. This is kind of a funny one. So what we want to pass in is the list of sources, which we've done, and then we want to pass in the initial pathway, which is 0, and then we want to join a path with an edge by adding, and we want to compute whether a path is less than another by using the regular less than. So this is like a very very general template. So now we're just going to implement basically what we had on our whiteboard. Oh, I guess we need to somehow store a map of all these edges as well, which is kind of annoying. Yeah. I like the reverse edges maybe. Yeah, I think that's the simplest way to do that. Um, I'll try to write this as clearly as possible. So we're gonna have our from. Gotta hydrate. So what we're finding here is we're just finding a map of, given a node, does another node point to it or not, and what's the cost. And the reason that we're doing that is because that's what we're going to need in order to implement this kind of, this is basically a for loop, right? So this is what we're computing with Dijkstra, and then this is what we're going to compute with our map. Yeah. So now what we're going to do is, so we want to go to U, and then we want to see if we can go from V to U. And if not, we skip this one. Otherwise, what we're going to do is we're going to set answer to the minimum of s dot distance. So we're going to find the distance from U to V plus the distance from V to U via a single step. And I guess we should see what this does if it's not reachable. Okay, so we need to check if it's reachable. Okay, cool. Wait, there could be more than one edge from V to U? Are you serious? There may be multiple. Wow, okay. This is a really tricky Atcoder contest. Like, okay, this should be initialized to n. Okay, so I guess what we want to do is this. Just take the minimum of those. Yeah, so here we said 50, but it should be 40. Cool, so now we said 20. So that's not good. I guess because this starts at 0. Yeah, okay. I guess I can do this. This is kind of messy, but okay, cool. So now we got 40, and then we just have to do this one last check. We need to print -1 instead of our infinity value. Okay, cool. So this passed the samples, so we can try submitting it. So definitely kind of a tricky implementation problem. Even having Dijkstra pre-written, like there's some edge cases to think about, as Caio Vieira pointed out in the chat. Cool. So we got accepted. So overall, this was a very tricky contest so far. Like, well, C was like had the potential to be really messy if not for that edges equals vertices trick. D had like kind of precision issues, which you could solve by using integer types. And then E just had this kind of random edge case. Like I don't really know the point of this other than making it slightly less convenient. If you have two roads connecting the same pair of towns, oh, what? You can even have a road that goes... You can even have a self loop. I didn't even consider that. So here this is v not equal to u, but we actually want to include v equal to u. Which luckily I did in my code. I didn't even think about that. I was like, oh, well, if there's a self loop, then this will skip over it automatically. This one. But apparently it won't. I guess it's good to learn how to deal with these kinds of edge cases. But yeah, alright, so here's F, and like from the standings again, F seemed like super difficult. Like, oh, nice. So yeah, like only a couple people solved F. From like my kind of sampled friends list. And like if we look at rated participants, oh, good number solved F. 55 though, which is a lot less than on some other contests. Actually, is Kenku updated now? Maybe it has the ratings. Wow, okay, yeah, so F was a 2300, which is... and D was considered much harder than E. That's funny. Okay, cool. So we'll try out F, but if it's too difficult and the stream is kind of going on for a while, I might give up. So yeah, no spoilers please, but did anyone in the chat actually solve F? Oh yeah, yeah, it's good they showed them in the samples. It's generally a good practice to read all the samples carefully. I did not do that here, but I definitely recommend it. Cool. So for F, okay, so basically for F what we have is we write some numbers on the board. Like here we have 6, 9, 12, and you can replace two numbers with their minimum or with their GCD. So one thing to note is the GCD is always less than or equal to the minimum. And if we replaced everything with the minimum on every operation, we'd find the minimum of the whole array. So the final number of the array, or the last number on the blackboard, is always going to be less than or equal to the minimum of the array. Yeah. Oh, and here n is 2000, so we probably have to do something like quadratic or something like that. Boolean cube. Should I start learning C++ with data structures? I think C++ is better than Java, but I don't know if it's necessary to switch. I got to Grandmaster on Code Forces using only Java before I learned C++, but now that I've learned C++, I think it's more enjoyable to do competitive programming using C++. Like it's more convenient. There's less kind of verbose code sometimes. You don't have to deal with like generics and like objects. Um, like structs and ints are a lot nicer. um, oh, Pratik, thanks for the bits. Um, but yeah, so I would say C++ is better than Java, but if you don't want to learn C++, like there's no need to learn C++. Um, oh, cool. So you're the #1 cheerer now. That's the little one badge, I guess, or bits leader. Um, should I learn data structures and algorithms by LeetCode? Should I buy premium or some course? Um, I mean, so if you have I would say that it's not necessary to buy any paid content um, in order to learn. Um, but if you have the money to spend and you think it would help you learn more efficiently or um, something like that, then I definitely recommend spending it. um, it's kind of up to your personal decision. Like if you have like a basically if you have a lot of time and you don't have any money, then I would say it's definitely possible to do everything without buying anything premium. And if you have a lot of money and not a lot of time, it may be useful to try to pay money to save time. But I think in general for data structures and algorithms, there are a ton of really good free resources. Like if your goal is competitive programming, the competitive programming community has a lot of really high quality, like, I don't know, blog posts and things like that. Somebody wrote a book on competitive programming, and for data structures and algorithms in general, there's like a million free courses. Like I think you can go watch like a university algorithms lecture, do the homework from that, things like that. And in general, I haven't really used LeetCode, but my impression is LeetCode is very focused on interview prep. So if you're interested in interview prep specifically, then maybe it's worth it. But if you're interested more in competitive programming recreationally, then I think there's kind of better resources than LeetCode. But yeah. And yeah, as Boolean Cube said, reading the documentation is really helpful for like data structures. Like CPP reference, just read that carefully when you have a question about how like set or map works or whatever, and that'll be really helpful. And Boolean Cube says, I covered the basics, but I don't know if I can solve the same level of problems in C++ as Java. Yeah, I think that's definitely true. Like when I switched from Java to C++, which was about 6 months ago, a little less than 6 months ago, I think I definitely had a lot of issues at first. Like I would keep getting like segmentation fault, like index out of bounds, forgetting to initialize things, um, getting confused about the syntax to use something with like templates and stuff. Um, and I'm sure that if I did a contest using C++, I wouldn't have done super well. But I think after a couple weeks, I was basically at a passable level in C++. I did some Atcoder contests in C++, I think just a few weeks after I switched, and did all my practice problems in C++, and it wasn't too bad. The reason for that, I think, is because most of the challenge in like competitive programming is not in like typing up the code, but in figuring out the algorithms and figuring out what to do. So as a result, it's kind of like I don't know, like during a contest, if it's like a hard contest, you probably spend most of your time on trying to figure out the problem anyway. So whether you're using a language that you mostly know or that you know really well doesn't make as big a difference. But yeah, there's definitely a bit of a learning curve when you switch languages. So I would say only do it if you like really want to. um, oh, Pratik, thanks for the bits again. Cool. Okay, so let's keep discussing F. I probably, well, if F is pretty easy, I'll solve it, but I think I probably won't fully solve F. I'll probably end the stream at some point. Like go eat or something. Especially because it seemed like it was pretty hard, but we'll take a crack at it. Okay, so in their example here, they're saying you can end with 3 if you take like the GCD of 6 and 9 and you get 3, and then you can just take the minimum repeatedly and end up with 3. So I think basically what we want to do is for all the numbers less than or equal to the minimum, we want to find for all the numbers less than, oh, thanks for the bits. Definitely appreciate all the support. And yeah, also if you don't have the means to subscribe or leave bits or anything like that, definitely there's no pressure to. I'm just doing this as a hobby, so it's you know, it always feels really good to get that kind of support, but it's not I don't need it. So if you need it, then you should keep it. Okay, cool. So basically I think the idea here is we want to look at all the numbers less than or equal to min and see whether it's possible to get them via a sequence of GCDs. Yeah, cool. And we don't need to, and when figuring out whether something's reachable, we don't ever need to use the min operation. In fact, I think we can, I don't think we need the min operation at all, do we? No, I guess we do. For example, if you had like 10, or let's see. So if you had something like 3, 10, 16, you could actually get 2 by taking the GCD of these and then the minimum of these. So you do need the min operation there at the end. But when you're trying to figure out what the smallest, or when you're trying to figure out what values you can get using some of the numbers, you don't need to use the min operation, because you can always just use if you have 2 numbers and you want to take their min and then take the GCD of one of them with something else, you could just use that one to start with. You don't need to like actually take the min at any point. Okay, so now we want to figure out what the possible GCDs of subsets of this array are. So how do we do that? So I guess if we want to see if a given number is possible, then what we can do is we can go through all the elements, and any element that's a multiple of it, we can take the GCD of all of those. And if we do that, then that will either be equal to this, or it'll be equal to something that's another multiple of this. So that kind of tells us one way to do this. The problem is this would end up being pretty slow if you want to query a ton of different values of x, right? Each one we can do in like O of n time, basically. But yeah, there could be like a billion values of x that we want to try. So let's see if there's a better way to do this. Yeah, okay, cool. So here, I guess 27 is the min, so we'd have to try a lot of stuff less than 27, and then maybe we can limit the number of candidates that we have to check in some way. So if we take, well, so we know it has to be a divisor of one of these numbers, but I think these numbers could have a lot of divisors. I'm not sure how many. I guess let's find out. Let's see, highly composite numbers. So I guess like this one is like pretty big. And let's see how many factors it has. This is 300 divisors. Oh, so that's like, okay, but I see. So we could have a bunch of numbers that each have like 300 divisors, and like maybe the divisors will be different or something. Um, hmm. Oh, maybe the total number of possible things we can get as the GCD are limited in some way. All right, let's try. So I'm gonna try implementing a like pretty naive solution, and I think it'll probably get time limit exceeded. But let's see if let's just check that it's at least correct. um, okay, so set GCDs. So we start with just 0. Alright, so this is definitely wrong, I guess. Let's see why. Oh, I guess this is not what we want to do. Maybe we can use a vector. So what we're doing here is we're gonna find the number of GCDs less than or equal to low, and I think that's gonna be our answer, assuming I implemented this right. Oh, and then we want to subtract 1 because there's a 0 at the beginning. Okay, cool. So this passes. It's probably too slow, but let's just submit it and get time limit exceeded. Cool. So it's running a, okay, nice. Time limit exceeded on the second test case. Very cool. Yeah, so I wonder how we can make this faster. Well, this problem could take me like a really long time, so I think I'll probably end the stream here. Maybe there's something you can do with like prime factorization or some other kind of trick like that. Yeah, seems like the size of this probably grows by like a lot. Well, it must, right? Because we're getting time limit exceeded. Big answer. Okay, I guess it provides some insight. I mean, that makes sense, I guess, right? This is wrong when we have a big length of this vector. Cool. So yeah, thanks everyone for tuning in. Hope you enjoyed, and you should subscribe to my YouTube and check out my Discord if you'd want to stay up to date with my future content. But yeah, thanks for joining. Alright, see ya.